So hello, good day. Today I'm going to give an example on how to find the roots using fixed point iteration method for multiple variables and nonlinear system. So here's my example. Find the roots using three iterations. Summarize it in a table. So here are my equations which has three variables. So we have 10x plus 5y minus 7z is equals to 12. And the second equation is 9x minus 4y plus 6z minus 18 is equals to 0. And the last is 8x plus 3y minus 5z is equals to 99. And the other side are my initial guesses for x sub 0, y sub 0, and c sub 0. So for the first equation, we're going to use x sub I plus 1, in which we're going to transpose all the non-x variable to the left side. So we have 10x plus, is equals to negative 5y plus 7c plus 12. And then divide both sides by 10. So we have x sub I plus 1 is equals to negative 5y plus 7c plus 12 is equals to 10. And then for the second equation, we're going to use y sub I plus 1, in which we're going to transpose all the non-y variable to the left side. So we have negative 4y is equals to negative 9x minus 6z plus 18, and then divide both sides by negative 4 so that y will remain. So we have y sub I plus 1 is equals to negative 9x minus 6z plus 18 is equals to negative 4. Now on the last equation, we're going to use the zi plus 1. So again, we're going to separate all the non-z variable to the left side. So we have negative 5z is equals to negative 8x minus 3y plus 99. And then divide both sides by negative 5. So we have zi plus 1 is equals to negative 8x minus 3y plus 99 over negative 5. Now on the first approximation, on the first we're going to use this x sub I plus 1. So we have x sub I plus 1 is equals to negative 5 multiplied by y sub 0, which is the initial guess for y sub 0 is 0.50 plus 7z, which is 1, plus 12 over 10. So we have negative 5 times 0.50 plus 7 times 1 plus 12 is over 10 is equals to 1.65. So the next one, we're going to use again this y sub I plus 1 and substitute all the initial guesses. So we have y sub I plus 1 is equals to negative 9x, which is 0, minus 6z, which is 1, plus 18 over negative 4. So we have negative 9 times 0 minus 6 times 1 plus 18 over negative 4. So we have negative 3. Now, next we're going to use z sub I plus 1. So we have here. So we have negative 8 multiplied by 0 minus 3 multiplied by y, which is 0.50, plus 99 divided by negative 5. So we have negative 8 times 0 minus 3 times 0.50 plus 99 divided by negative 5. So we had negative 19.5. Now, here we're going to put the answer on the table. So the x sub I is equals to 0, 0.50, and then 1, in which on the first iteration, our x sub I plus 1 is 1.65, y sub I plus 1 is negative 3, and z sub I plus 1 is equals to negative 19.5. Now, on the second approximation or second iteration, again we're going to use the same formula, but our new value for x sub I, y sub I, and z sub I are the x sub I plus 1 and y sub I plus 1, and then the z sub I plus 1 of the first approximation. So x sub I plus 1 is first negative 5, the y sub 1 plus I is negative 3 plus 7, z, which is negative 19.5, plus 12 over 10. So we have negative 5 times negative 3 plus 7 times negative 19.5 plus 12 equals 10 is negative 10.95. Now for the second one, which is I sub I plus 1, we have negative 9 multiplied by the x, which is 1.65, minus 6z, which is negative 19.5, plus 18 is equals to, divided by negative 4 is equals to negative 9 times 1.65 minus 6 times negative 19.5 plus 18 over negative 4. So we have negative 30.0375. Now, next is the z sub I plus 1. So, negative 8 multiplied by the value of x on the first iteration. So, we have 1.65 minus 3y, which is negative 3, plus 99 divided by negative 5. So, we have negative 8 times 1.65 minus 3 times negative 3 plus 99 divided by negative 5. So we have negative 18.96. Now, on the third iteration, approximation, before we're going to put this. So the so we're going to put 1.65, negative 3, negative 19.5, And then the new value for the second iteration for the x sub I plus 1 is negative 10.95, and then the y sub I plus 1 is negative 30.0375, and on the z sub I plus 1 is negative 18.96. Now, before we're going to proceed to the next iteration, we're going to get the relative error for the x variable, y variable, and the z variable. So relative error for x is equals to the absolute value of the new value minus the previous value over the new value times 100 is equals to negative 10.95 minus 1.65, 10.35, so times 100, so we have 115.07%. Now for the relative error of y, we have absolute value of negative 30.0375 minus negative 3 over negative 30.0375 times 100, so we have negative 30.0375 minus negative 3 over negative 30.0375, so we had times 100, we have 90.01%. Now for the relative error of the z variable, so we have negative 18.96 minus negative 19.5 over negative 18.96 times 100, so we have negative 18.96 minus negative 19.5 over negative 18.96 times 100, so we have 2.85%. Now we're going to proceed on the third iteration. So on the third iteration, again, x sub I plus 1 is equals to negative 5, the new value which of the y, which is negative 30.0375 plus 7z, which is negative 18.96 plus 12 divided by 10, so we have negative 5 times negative 30.0375 plus 7 times negative 18.96 plus 12 divided by 10, so we have negative 2.947. Now for the y sub I plus 1, we're going to use negative 9. X is equals to negative 10.95 minus 6z, which is negative 18.96 plus 18 divided by negative 4, so we have negative 9 times negative 10.96 plus 18 divided by negative 4, so we have negative 29.16. Now, on for the z sub I plus 1, which is negative 8 multiplied by x is negative 10.95 minus 3y, which is negative 30.0375 plus 99 divided by negative 5. So we have negative 8 times 10 point negative 10.95 minus 3 times 3 minus 3 times negative 30.0375 plus 99 divided by negative 5. Negative 55.3425. Now, we're now going to get the relative error for the third iteration. So, I'll just put it here. So, relative error x is equals to absolute value of x, which is negative 2.947 minus the previous value, which is negative 10.95 divided by negative 2.947 times 100. So we have negative 2.947 minus negative 10.95 divided by negative 2.947 multiplied by 100. So we have 271.56%. Now for the relative error of y, we have the new value, which is negative 29.16 minus negative 30.0375 divided by negative 29.16 multiplied by 100. So we have negative 29.16 minus negative 30.0375 divided by negative 29.16 multiplied by 100. 3%. Now for the relative error of z, we have negative 55.3425 minus negative 18.96 divided by negative 55.3425. So times 100. So we have negative 55.3425 minus negative 18.96 divided by negative 55.3425 multiplied by 100. So we have 65.74%. Now we're going to, we don't have a relative error. So our relative error for the second iteration for the x, we have 115.07%. For the y, we have 90.01%. And for the z, we have 2.85%. Now, on the third iteration, our new value is negative 10.95, negative 30.0375, and z is negative 18.96. And our new value for x is we have negative 2.947 For y, we have negative 29.16. And for z, we have negative 55.3425. Now, for the relative error on the third iteration for the x, we have here 271.56%. For y, we have 3%. And for z, we have 65.74%. But as I was reviewing my whole answer, my all over answer on the third iteration, specifically on the y sub I plus 1, I got the wrong answer, which this negative 29.16 is not the correct answer. Rather, it is equals to negative 57.58. So I'm going to calculate again the third approximation. So for the third approximation, x sub I plus 1 is equals to negative 5y, which is negative 30.0375 plus 7 multiplied by z, which is negative 18.96 plus 12 divided by 10. So we have negative 375 plus 7 times negative 18.96 plus 12 divided by 10. So we have 2.947. And for y sub I plus 1, we have negative 9 times x, which is negative 10.95 minus 6z, negative 18.96 plus 18 divided by negative 4. So we have negative 9 multiplied by 0.95 minus 6z, which is negative 18.96 plus 18 multiplied by negative 4. So we have 57.58. Now for the z sub I plus 1, we have negative 8x, which is negative 10.95 minus 3y, which is negative 30.0375 plus 99 divided by negative 5. So we have negative 8 times negative 10.95 minus 3 times negative 30.0375 plus 99 divided by negative 5. So we have negative 55.3425. I forgot the negative here. So now we're going to calculate its relative error. So for the relative error of x, we have the new value, which is the absolute value of 2.947 minus the previous value, which is negative 10.95 divided by 2.947 times 100. So we have 2.947 minus negative 10.95 divided by 2.947 times 100. we have 471.56%. Now for the relative value of y, we have the absolute value of the new value, which is negative 57.58, minus the previous, which is negative 30.0375 divided by negative 57.58 multiplied by 100. So we have negative 57.58 minus negative 30.0375 divided by negative 57.58 multiplied by 100. So we have 47.83%. Now for the relative error of z, we have the absolute value of the new value, which is negative 55.3425, minus the previous, which is negative 18.96, divided by negative 55.3425 multiplied by 100. So yeah, negative 55.3425 minus negative 18.96 minus negative 55.3425 multiplied by 100. So we have 65.74%. Now we're going to write again the answer on the table. So here is it's not negative, but it's negative 55.58, and it's not negative here. So on the relative error for x, we have 471.56. So it's not 271, but it's 471%. And 47.83%. It's not 3%, but it's 47.83%. Now for the, it's 65.74, so it's still the same. So that's how you get the root of fixed point by using fixed point iteration method with multiple variables and a nonlinear system. That's all, and thank you for watching.